So, what is actually going on inside the mind of an AI, like ChatGPT? You've probably wondered, right? It can feel like some kind of magic. Well, today we're going to pull back the curtain and peek inside that black box. We're going to demystify how these incredible machines learn to talk. And you know what? The answer is a lot simpler and, honestly, a lot weirder than you might think. Okay, let's start with a little thought experiment. Imagine you find this movie script, but the last line is ripped off. How would you figure out what the character was supposed to say? Think about it. The answer to this little puzzle, right here, is the key to understanding how this entire AI thing works. And here it is, the secret. At its absolute core, a large language model, or LLM, is just a spectacularly powerful machine that's built to do one single thing: predict the most likely next word in any given sentence. That's it. It's not thinking, it's not feeling, it is calculating probabilities. So forget any ideas about a conscious robot for a minute. Just think of an LLM as the most powerful, souped-up autocomplete you've ever seen. It's like a magical word predictor, and now we're going to see exactly how that trick is done. See, the model doesn't just pick one word. What it actually does is create this huge, ranked list of every possible word that could come next, and it gives each one a probability score. Now, to keep from sounding like a boring robot, it sometimes, rolls the dice and picks a slightly less likely option. That little bit of randomness is exactly why you can ask it the same question twice and get two totally different, totally natural sounding answers. Okay, but how in the world does it get so good at this? How does it learn grammar and facts and even how to reason a little bit? Well, the whole process really comes down to three core ingredients that are used to build this digital brain. First, you've got data. That's the fuel. Then you've got the architecture. That's the engine. And finally, you have the training process, which is basically like teaching that engine how to run. So let's break each of these down, starting with the data, because the scale here is, well, it's just mind-boggling. So, ingredient number one is a truly astronomical amount of text. The training data for just GPT-3 was 45 terabytes. That is millions and millions of books, countless articles, and a huge chunk of the public internet. It's a volume of words that is it's almost impossible for a human brain to even comprehend. Want to put that into human terms? Okay. If you decided to read all of that text 24/7 with zero breaks for sleeping or eating, it would take you over 2,600 years. And get this, newer models are being trained on even more data than that. It's wild. Now, for the model to actually learn from all this data, it needs a way to adjust itself, right? This is where parameters come in. And honestly, the best way to think about a parameter is like a tiny tunable dial on a giant machine. The model's entire behavior is just determined by how all these different little dials are set. And when we say a large language model, we really, really mean it. GPT-3 has 175 billion of these dials. Every single one is adjusted over and over and over again during the training until the machine gets incredibly good at predicting the right word. We are talking about a machine of almost unimaginable complexity. So we've got the data and we've got the dials. But how does the machine actually process all of it? This brings us to that second ingredient, the architecture. And this is where we find the real secret sauce, a revolutionary idea called the transformer. You see, before 2017, AI models had to read text one word at a time. Super slow, super inefficient. Then, researchers at Google introduced the transformer. It's a new kind of neural network, or digital brain, and its superpower is that it can process entire sentences or even whole paragraphs all at once. I absolutely love this description. They soak it all in. This parallel processing is what makes training on 2,600 years worth of text even possible in the first place. It lets the model understand the context of a single word by looking at every other word around it, all at the exact same time. So how does it do this? Well, it uses this really clever mechanism called attention. First, every word gets turned into a long list of numbers that represent all its potential meanings. Then, the attention mechanism lets those numbers kind of talk to each other and weigh the importance of every other word in the sentence. So, if the model sees the word bank next to the word river, the attention mechanism says, hey, that connection to river is super important, and it helps the model understand we're not talking about money. It's all about context. All right, we now have a super fast, context-aware word predictor. That's great. But how does that thing become a helpful assistant that can actually follow your instructions? This brings us to our final ingredient, the training process itself. The training pretty much happens in this one massive loop. The model gets a piece of text, like the sky is, and it makes a guess. Now, at first, all those 175 billion dials are set randomly, so it might guess something totally nonsensical, like bug. Then, it compares its guess to the actual answer in the data, which is blue, and an algorithm slightly adjusts all of those billions of dials to make the right answer just a tiny bit more likely next time. Now, just repeat that process trillions of times. But believe it or not, everything we've just talked about, that's only part one. That's called pre-training. It's what teaches the model grammar, facts, and just how language works. But to make it a useful assistant, there is a second, absolutely crucial step called fine-tuning. This is where real humans get involved. They interact with the model and they flag bad or unhelpful answers. Their corrections are then used to tweak the parameters even more, teaching the AI to be helpful, to be harmless, and to align with what we, the users, actually want. So, we've built our model. It has been trained on a library's worth of text and then fine-tuned by actual people. What happens when we unleash this unbelievably complex system on the world? What does it all mean? I mean, think about it. We've gone from this simple, abstract idea of just predicting the next word through these incredibly complex networks and training processes to create something that can generate text that is almost indistinguishable from a human. And it is already changing how businesses operate. Right now, today, businesses are using these models to power intelligent customer service chatbots, which frees up humans for the more complex problems. They're being used as creative partners to help generate articles, emails, and marketing copy. They're even acting as co-pilots for software developers, helping them write and debug code. And really, this is just the beginning. But here is the most fascinating and maybe the most unsettling part of this whole thing. These complex abilities like reasoning or creative writing, they weren't explicitly programmed in. They are what's called emergent phenomena. They just appear out of the sheer scale and complexity of the system. Even the researchers who build these things admit it's incredibly challenging to know exactly why it makes the predictions that it does. Which leaves us with a final, massive question. By teaching a machine to simply predict the next word on a colossal scale, it seems like we have stumbled upon something much, much more profound. We've built this powerful tool that can communicate with us, but the true nature of what's happening deep inside those billions of parameters, well, that remains one of the most exciting mysteries of our time. What do you think is really going on in there?
If you're interested in science, subscribe now to be part of this family and be the first to know about exclusive tips.